Hey super scientists, we're starting a periodic table unit with PT1. So I'm using PT as an abbreviation for periodic table. We're going to start off by looking at the periodic table and looking at how you can use the information that you find on the periodic table. But first, let's look at a little history. Dmitry Mendeleev. So Dmitry Mendeleev is the scientist who's referred to as the father of the periodic table. He is a Russian scientist, and he is the one who discovered that there were different commonalities between some of the different elements. And so as he was grouping those together, he looked at their atomic number and was able to align some of the different elements. And he published the first periodic table in the 1860s. So since then, of course, in looking at these two different examples, the periodic table has undergone a lot of different changes and updates, and we've also discovered a lot of different elements, new elements, and some fabricated synthetic elements since then. There are so many different scientists that were important to the history of the periodic table and also discovery of atoms and different elements. But we'll be talking about radioactivity as we progress throughout this unit. So I wanted to mention to you a few different scientists that were important in learning about radioactive materials. Henry Becquerel is the scientist who discovered radioactive decay, and he studied uranium, and he basically had placed a piece of uranium on top of some photographic paper, and then when he came back into the lab the next day, he realized that that photographic paper had been developed, and it kind of left this imprint, and so that he knew that there had been some kind of emission of energy. Marie Curie is a scientist who also studied uranium, and this is a photograph of Marie Curie, and she is the one who discovered radioactivity and named this emission of energy as radioactivity. And she actually ended up dying as a result of the absorption of energy from cancer based on her research that she did in studying uranium, and her lab notebooks actually absorbed a lot of that radioactive material, and they're still radioactive to this day. So the periodic table is arranged in several different ways, and you see lots of these little boxes on the periodic table, of course, and this one has it color-coded just to break it up into the metals, nonmetals, and metalloids. But as we look at the arrangement of these elements, they're vertical arrangements and also horizontal arrangements. So the horizontal rows are called periods, hence periodic table. So this whole thing going across is a period. And the vertical columns are called groups and also may be referred to as families. So vertical goes up and down. So this is vertical. This would be group 1. So for example, group 1 metals, the alkali metals, will react violently with water. Group 2 is also pretty reactive, but it is not reactive in the same way that group 1 is reactive. So each of the groups has properties that are in common with those elements. So all the elements that are in group 1, all of them are going to be highly reactive, specifically with water. Another example is group 18. Group 18 elements, those are noble gases, and those elements do not like to form compounds. So that is the characteristic that kind of unifies group 18 elements. So the periodic table is just a chart. It shows all of the elements, and it shows them arranged by increasing atomic number, going from left to right. So if you look over here, our first element is hydrogen. So that is the atomic number right here, 1. And we go straight across, and there's 2, and that is helium. We go down to the next row, 3, lithium, 4, beryllium, and so on. So you read it from left to right, and it's arranged by increasing atomic number. So let's unlock the secrets of the periodic table. So each square on the periodic table represents one element, and it has some information about each element within that square. So for example, let's look at iron. Iron is the name of the element. The chemical symbol, which is the 1 or 2 letter abbreviation for the element, is Fe. And the atomic number is this number right here, and the atomic mass is right here. So in taking a look, just to recap that information, we have the atomic number, we have the chemical symbol, the name of the element, and also the atomic mass. So that's the information that's directly listed for each element on the periodic table. So I have a nice little graphic here, and this is going to show you a little bit of the information that you can further gather from the periodic table. So our atomic number for iron, again, is 26. The atomic number is going to tell you the number of protons. The number of protons also happens to be equal to the number of electrons, and that's why atoms are going to be neutral. So the atomic number is going to tell you the number of protons. So for iron, the atomic number is 26. That means that it has 26 protons. The atomic mass. So for iron, 55.847 is the atomic mass. The atomic mass tells us the mass of the atoms. And usually the atomic mass is going to be a decimal number, and that's because it's an average. It's an average of all the different forms, all the different isotopes of that particular element. The mass number is going to tell us the sum of the protons plus the neutrons. And the mass number is not directly given on the periodic table. You have to do one little thing. So to find the mass number, we're going to look at the atomic mass, which is our decimal number, and just round it to a whole number. So 55.8 is going to round up to 56. So 56 is our mass number. So again, to find the mass number, we're going to look at the atomic mass, and you just round it to a whole number. 55.8 rounds to 56. And that tells us the sum of the protons plus the neutrons. So why is that important? Well, let's circle back to all the information that you can find on the periodic table. So if you want to find the protons, then you look at the atomic number. If you want to find the number of electrons, you look at the number of protons, or just look at the atomic number, because they're all three equal. It's not a trick, I promise. And then the number of neutrons. So if you want to find the number of neutrons, we know that the mass number is going to tell us the sum of the protons and neutrons. So if we know the atomic number, if we know the number of protons, then we can figure out the number of neutrons given the mass number. So to find the number of neutrons, we're going to take the mass number and subtract the atomic number. So 56 minus 26 gives us 30 neutrons for iron. So this is a little graphic that will help you to remember that information. APE-man, APE, atomic number equals protons equals electrons. And man, mass number minus atomic number equals the number of neutrons. So APE-man will help you to remember the information that we were just looking at on the previous slide. Let's do a couple more to practice together. So this is the box for phosphorus on the periodic table. That's literally just a screenshot straight from the periodic table. So phosphorus, our chemical symbol is P. The atomic number for phosphorus is this big number right here, 15. The atomic mass, 30.97. The mass number, so that's going to be 30.97 rounded to a whole number, so that would be 31. The number of protons, remember, is equal to the atomic number, so that's going to be 15. The number of neutrons is going to be the mass number, which is 31, minus the atomic number, which is 15. So 31 minus 15 gives us 16. And our electrons, remember APE-man, atomic number is equal to protons is equal to electrons. So our number of electrons is going to be 15. Let's look at gold, AU. So the atomic number for gold is 79. So this is our atomic number. The atomic mass, it's this big number right here, 196.967. The number of protons is going to be 79. The number of neutrons is going to be 118. So that's a little bit of math there. So to find the number of neutrons, remember we're going to take the atomic mass and round it to a whole number, which will then be called our mass number. So 196.9 is going to round to 197. That's how we got that number. And then we're just going to subtract 79, which is our number of protons. So if you put that into a calculator, that gives you 118. And our number of electrons is equal to the protons is equal to the atomic number. So that's 79. Another example here, hydrogen. Hydrogen is a little bit unique. So hydrogen, our atomic number is 1. Our atomic mass, 1.008. Our number of protons, 1. Our number of neutrons, 0. So this is unique to hydrogen. So why does hydrogen not have any neutrons? because if you take our atomic mass, round it to a whole number, so 1.0 rounds to 1, 1 minus 1 is 0. So hydrogen doesn't have any neutrons. And how many electrons? 1, because the atomic number is always equal to the protons equal to the electrons. And our last example, manganese. So manganese, the atomic number is 25. The atomic mass, 54.938. Our number of protons is equal to the atomic number, 25. Our number of neutrons is 54.9 rounded to a whole number, so that'll be 55 minus 25. So that is our mass number, which would be 55 minus 25, so that gives us 30. And our number of electrons is going to be equal to the protons equal to the atomic number, 25.